Let's look at a couple of examples on how to classify differential equations. So the first example, we're looking at dp dt equals k times little p times capital P minus p, where k and capital P are constants. So the first thing we have to do is decide, is this an ordinary differential equation or a partial differential equation? Well, since there are no partial derivatives, this is an ordinary differential equation. Now let's look at dependent versus independent variables. The dependent variables, they show up on top when you look at the derivative. So in this case, the dependent variable is p, and then the independent variable is t. The order of the differential equation is the highest derivative, and there's only dp dt, so the order is 1. So now we have to decide whether this differential equation is linear or nonlinear, and that means we have to look at the dependent variable, and we want that the dependent variable shows up to the first power only. Now we see that we have p to the power 1, but we also have a p to the power 1 here. And if you multiply that out, you get a p squared. And that means it's nonlinear. Okay, let's move on to the next example here. We have 8 times the fourth derivative of y with respect to x equals x times 1 minus x. This is an ODE. There are no partial derivatives. The dependent variable is y, and then the independent variable is the x. The order of this differential equation is the highest order derivative, so the order is 4. And now we have to see, is it linear or nonlinear? Again, we have to look at the dependent variable and the powers of that dependent variable. We see there's a fourth derivative, but it's to the power 1, and there's no more y in here. So everything is to the power 1. That's linear. Again, the x times x gives you x squared, but that's the independent variable, so that doesn't matter in determining whether or not this differential equation is linear or nonlinear. And then the final example here, we have a differential equation, a second partial derivative of u with respect to x, and the second partial derivative with respect to u, or of u with respect to y, equals 0. Now we see the partial derivative, so this is a PDE, and then the dependent variables, that's the variable that shows on top, that's u, and then the independent variables are the variables that show up on the bottom here, so that's x and y. The order is the highest order derivative, so that's the second derivative here. So we have 2, and then linear and nonlinear, we only have to determine that when it's an ODE, and this is a PDE, so this is not applicable. And then just a note for when you're studying for the exam, for the first exam, this is the type of problem that you will see on the exam. So, exam questions. On this section will be similar to these examples.